When I say there's no such thing as an error, what I mean is there's no such thing as just an error, or there's no such thing as a pure error that isn't also falling into one of two other categories that we're going to talk about right now. Before I get to the rest of the video, I would just like to call out that this is a proposal, sort of an idea, not an established methodology in professional programming. If you are new to programming, you should not take this as the way that you ought to start doing things or the way that anybody else does things. I've been programming professionally for about 10 years. This is a concept, some way that I'm trying to work through something, a way that you could look at it and probably has a lot of problems right now. So if you are an experienced programmer or if you are a new programmer and you just want to kind of stretch your brain a little bit and see what ideas there might be, come in, check it out, see if you like it, see if you're disgusted by it. But please, if you're learning programming, this is not meant to teach you what you ought to be doing. I just wanted to get that disclaimer out there. I think that we tend to handle these two different cases as errors altogether, and it might be appropriate for us to start trying to treat them differently and maybe handle them differently. And we might end up having more stability around what we're doing if we do that. So traditionally what we do is we have some expected states that our program can get into. We have unexpected states that they shouldn't get into, and we use error handling to detect when one of these unexpected states comes up, and we handle the error. The problem we're running into is that sometimes the unexpected state we run into is something that should never, ever be possible to happen, and other times it's something that if it happens, we want to tolerate it. Right? If you're running a low-level program and you can have memory bugs, these things should never happen, ideally. If you're running a web server, you should be able to have an error, maybe report the error, and tolerate it, and proceed and continue and stay up and handle other things. So instead of having errors be defined as this one big catch-all for both of these cases, I am going to propose that we start to think about it maybe more in terms of unacceptable state and unpreferred state, which is still within our expected state. So if we look here, we've got expected and unexpected. Unpreferred is still in expected. So an example might be, I write code that receives no user input and it breaks. It's had nothing but what I've programmed it to do, and it still breaks, means that I've done something wrong. We get into an unacceptable state. If I'm accepting user input and they give me something that I wasn't really expecting, that isn't really what I would technically call unexpected state, because you always can expect users to provide any kind of data they might want to, right? So you might say, I don't expect that data to be in my system. If I've implemented enough stuff to prevent that from getting in there, that might be a good use for unacceptable state, because you're checking your own code. But unpreferred state would be, I would like kind of a way to catch the things that shouldn't really be the case, but I expect might be the case. And we're going to want to handle them differently. So I'm going to kind of give a proposal here on a way that we might do that. So here's a really simple program. We have a main function here, and all it does is call another function and return the result of that function, right? And log the result for us. And all that function is doing, we're not accepting any input. We're using these functions here, these arithmetics, and they're doing some pretty simple stuff. And the reason I had these do arithmetic functions like this is because as a demonstration, one of these has a bug, and we're going to kind of use this as a simple example to go and find the bug, or at least be able to detect that there is a bug happening. And what are we going to do about that? So we're adding 5 and 5. We're going to get 10. We're going to divide the result of that 10 by 2 to get 5, and we're going to multiply the result of that, which is 5, by 5, and we're going to get 25, and our result should be 25. So if we run this, we get negative 25, which is not at all what we wanted. So we've got a bug in one of these functions somewhere, right? How could we make our program tell us that this is not okay? What are we in? Like, we're clearly in an unexpected state, but if we drill down into what exactly we're in of these possibilities, we know we're not in a preferred state. Are we in an unacceptable state or an unpreferred state? In this case, because this is all of our own code, and we know that this should be 25 if these functions are operating as they should, means that they aren't. Means that if our code works, this should never happen. So this is an unacceptable state. So what we can do to report that is use an assertion. So I've created and imported here a very simple implementation of a basic assert, and we're going to assert that z, which is our result here, is greater than 0. There's no reason given this. We add these 5 numbers together, we add this, we add this. In this case, we could even say z equals 25. We could say z should always be 25 and say z should always be 25. If we go to receiving user input and they give us a 5 or some other positive number, we should always end up with a positive number. So we could say z should just be positive. In this case, though, we know it should be 25. So z should always be 25 is going to be our assertion. And if we run that, we're going to crash. Z should always be 25. So we know something has broken. All right, so let's go back in here and find the bug. The bug is in the multiply function here with this little negative sign. If we remove that and come back and run, we're all good to go. So assertion can be used to say, this has to behave this way. We're going to crash the entire program because we're in an unacceptable state. And one of the things I'm going to talk about is that unacceptable state effectively means that we ought to crash our program. Unpreferred state, and this is where my current proposal of a way you could handle this goes in. Unpreferred state should crash our function call. I'm going to show you what I mean by that. Unpreferred state should crash our function call. That's what's going to separate unpreferred state from different cases in a potentially preferred state. All right, so let's accept some user input here. You've got a prompt to enter a number. We're going to parse it as an integer, and there's enough errors that could crop up with this. We're going to pass over that for right now. We're going to handle the whole math thing up here. So we're going to pass that into here, and we're going to put that in here as the first add. So okay, so now if they give us a 5, everything's going to happen the way it has been. So let's do that. Let's enter a 5. We get a 25. Wonderful. We give it a 6. What am I doing? Give it a 6. Z should always be 25. No longer the case. What is true, though, as an assertion about this? What can we know must always be happening? Well, if they give us a positive number, we should always end up with a positive number. Can we expect for sure that they're going to give us a positive number? Well, let's start out assuming that they will. Z is going to be greater than 0, and we say Z should always be greater, should always be a positive number. All right, that's our assertion. So now we can run this with a 6 and get a bigger number. We could run it with a smallish number and get that. All right, so we're doing fine. The assertion is there, making sure our code's doing what it should, making sure we don't have any bugs up here. So now, of course, and it's not should be 25 anymore. None of these comments are correct anymore. So now, with user input, of course, we can provide anything we want. We can provide a -9. And yes, I realize we could provide a G and break this right here. We could provide a string of other characters. We're not going to handle that right now. We've got enough to deal with the math situation. Z should always be a positive number. The assertion crashed our program. The problem with this is not that our code itself is broken. Our code does do what, when we look at it, it's supposed to do. If a negative number comes in here, it's going to produce a negative number, and given what we have created and what we expect this to do, that is what it should do. What we don't want is for somebody to give us a negative number. But we have to expect, remember expected versus unexpected, we have to be able to expect that they could give us a negative number even if we don't want them to, right? So it's going to be an unpreferred state. Unacceptable crashes our program. Unpreferred is going to crash our function. So we're going to come in here and we could just handle this by saying if I is, less than or equal to 0, then we're going to throw an exception, whatever, etc. The problem with throwing exceptions right now is because the terminology around that is error, which is not really communicating to us whether we want to call this an unacceptable state or an unpreferred state. So I've implemented a function in here called prefer. And we're going to use that, and I'm going to kind of explain the idea of what this might do. We're going to say prefer I to be greater than 0. And we're also going to give it some number to fall back to. We're going to crash this function, saying that we've entered into an unpreferred state. We're going to crash the function with some number. Let's fall back to, say, 0. If we call do something and we give it a negative number, we're going to fall back to 0. So if we run that and we give it a negative, all right, why have we broken the whole thing? Why did the whole program crash? And it's because crashing this function in JavaScript, the implementation of this is using exceptions, using the throwing of exceptions to actually pull off the crashing of the program. The only way to stop execution here is either to have an if statement where you do one thing in the if and one thing in the else, or to return, in which case we have to return. We could throw an if statement around here and return only if a conditional is met. But if we want to be calling out very clearly that this is not another just possible expected state, it is an expected state, it's not another preferred state, but we want to call out this is an unpreferred state. This is something that we don't really want to proceed with our code in this function if that's the case. We're going to call it out this way. It is going to throw an exception, but up here we're going to kind of catch it. We're going to catch it by, okay, this is what made sense to me. Prefer to call it out. I'm doing it backwards, referp. It's like reverb, but with a P. So we're going to referp it. Referp. And we're going to wrap that. All right. And because of the way JavaScript works in the implementation, I've got to put it in there as a Lambda function. So we referp this. And what that means is that when I look at this call, I can tell that this might get into an unpreferred state, right? If this might get into an unacceptable state, right? If it's possible that function could get into an unacceptable state, I don't need to do anything here because it's going to crash the program if it does, right? But if it gets into an unpreferred state, then that function is going to crash. Do something is going to halt before it really gets through, and I need to know that that happened, right? So I'm going to referp, and that's going to mean I'm calling attention to the fact that this is here, and I'm pulling that value, this value, out of it. So if I run this, I realize this is confusing, just kind of hang with me. If I run this and I give it a regular number, we're proceeding fine. If I run it and I give it a negative number, we end up with a 0. Why do we end up with a 0? Because we passed this out when we crashed the program. And when we grabbed it, when we caught it, and yes, this is equivalent to try catch. And if you're asking yourself, why don't we just use try catch? I'm going to hopefully get there. But the main point is try catch makes you think it might be an error that's supposed to crash the program. In this paradigm, we're kind of hoping to clearly communicate that this is not going to crash the program. This is not an unacceptable state. This is not something that means our program is broken. This is something that we want to handle because it's other than our main thread of logic, which is our preferred state. All right, if this doesn't seem so far to be just a horribly offensive idea, then stick with me while we go through and see if we can handle this part into situation here. So if we wanted to say our program's broken if the string can't be parsed as an int, then we might write ourselves a nice little utility function for a number and return not is not a number on n, because that right there doesn't look very nice. So we're going to say if it is a number, we're going to return true on there. So we're going to assert that I is a number, right? Because if you parse int on a string that can't be parsed as an int, parse int very seamlessly fails and just returns a value called not a number. This isn't a number. And that's one approach to unpreferred state, right? We can't really tell looking at this that that's the case, but we do know the language well enough to know that that's what we're going to get. So we're going to assert that it's a number, and if it's not, then we say I must be a number. Crash the program. So now we have designed a program that is designed to crash. How wonderful. -5 gives us a 0. That's okay. -9 gives us a 0. Okay. So why is our assertion not crashing? Because I is a number. G, crash. I must be a number. Everything breaks. So the user is now able to crash the program by giving data that we ought to know they might give. So unpreferred state is going to include letters. So we're going to prefer. Now hold on a second. If we do a prefer here, it's going to crash this function, the main function, and the main function is our program, right? So prefer is actually not appropriate here. This prefer paradigm really is only when you are working in a function and you want to communicate to the caller of the function that it got itself into an unpreferred state. So maybe we can refactor this into something where that preferring deal can be handled. So let's do get input, and we'll put all of this in there. And we'll return the result of that. Return I. And now we can do i's get input. So this is about the same as we had, just a little refactor. Let's, make sure that all of that's visible. Let's try that. Give it a K, a J. Yeah, it fails kind of seamlessly because it's going to try to parse the int. It's going to try to go in there. It's just going to do what it can and not really be able to do anything. We could add the assert if we wanted to. Assert is num I. I must be a num. And now if we give a letter, we break. Great, but we don't want to do that. So in this case, we could put prefer in here. This is actually not going to be the appropriate use case for prefer, because what does prefer do other than just calling out that we've gotten into an unpreferred state? It crashes the function, but where are we? We're at the end of the function. There's nothing else to do here, so crashing here doesn't really make a whole lot of sense other than to not return this. So this is actually a very appropriate case for returning Go style, which is to say, instead of just returning the value and possibly a message, right? A null message if nothing has gone wrong, or a if is not a number I, then we'll return I is null, and message is you must give a number. And then when we deal with it here, we don't even need the referp, we just do get input. But where we can get I here, we can either handle it like this, or I should say, we either not handle it like this and just proceed, or we also grab message and then we say if message, then log the message and return, right? So we can do something like that. This is not really accomplishing the goal of calling out that we're in an unpreferred state, other than the fact that if we were in an unacceptable state, we would be throwing an assertion in here. So in a way, using a function like prefer maybe useful, maybe not. You might just want to go with a paradigm where you say, I'm going to assert everything that's unacceptable, and I'm just going to have everything else be together, and not really going to make it clear if it's a preferred state or an unpreferred state. What prefer can do is try to delineate between these two things, right? To say, my if statements, my normal kind of logic flow is preferred state. And when I use that prefer method, that means that I've gotten into an unpreferred state somehow, or I can. So up here, instead of having this be an if statement, we could kind of accomplish this same thing using that prefer method. And we just do it. My printer's trying to print with no paper. Sometimes I feel like I'm trying to print with no paper. All right, nubmer. I said nubmer. We could do the same thing as prefer, that it is a number, and do the whole I null message situation otherwise, right? So this is the equivalent of this, except that to catch that, we also need to down here throw referp onto this, right? And then everything else remains the same. So if I make an attempt at running this, and crossing my fingers I didn't forget something. If I give it a 5, that's fine. If I give it a -5, it's a 0, because in this do something method up here, we did a prefer and we said it needs to be bigger than 0, otherwise we're going to return 0. And down here, we kind of seamlessly just allowed that to come through by doing a referp with no additional cases. And so that's a number. And if we run it with a bunch of letters, you must give a number. We handle that specifically and explicitly up here. So the funny thing is, this is Go style error returning, but the prefer and referp stuff is using exceptions under the hood. So I'm going to open this up. Assert is really simple. Screenshot that if you want. I might put it in a paste bin and throw it in the description. But that's just like a really, really simple implementation of what an assert would do. And then here's the prefer and referp. And I'm actually using assertions in there to make sure that they do what they're supposed to do. Feel free to screenshot that too. But yeah, it is using a try catch in referp, and it is using a throw in the prefer. So it's using that mechanism in JavaScript to do the thing of like, I want to crash, I want to send up, and I want to keep crashing until somebody says, this is how I want to handle that unpreferred state. So this is a paradigm that you could use. Maybe you don't want to use prefer and referp because it's not a real word. Maybe nobody else who uses your code is going to have any clue what's going on here if you try to use those things. So maybe you want to stick to traditional error handling. But in any case, I'm curious what your thoughts are on whether making clear in our code the difference between what is unacceptable and should crash the program and what is unpreferred and should maybe crash that function call, and whether that's a good way of going about things.